Welcome to Vertica Girl. In an earlier video, we broke down K-safety, which is basically how Vertica copies every segment to another node so your data survives a node failure. So as long as your data is safe, the database keeps running, right? Not always. In enterprise mode, there is second rule working alongside K-safety and it's called Quorum. And it can shut down your database even when every byte of your data is perfectly safe. That's what we are decoding today. Let me show you why. In Vertica, Quorum refers to minimum number of active cluster nodes required to keep the database running safely, while K-safety refers to the level of data redundancy and fault tolerance. Both work together to prevent data corruption during node failures. Quorum is one simple rule. To stay running, more than half of your nodes have to be up. For a 5 node cluster, it's 3. So 3 is your quorum threshold, the line that you can't cross. Right now all the 5 nodes are alive, 5 out of 5. So well above the line, which means the database is running. Now 2 nodes fail. You are down to 3 live nodes. What are those? N1, N2 and N3. And 3 is exactly the quorum threshold. More than half of the nodes are still up in the cluster. So the quorum is met and the database keeps running. Basically you are sitting at the bare minimum, but still you are safe. Then a third node drops. Now what happens? Only 2 nodes are alive, which is below the threshold of 3. So the quorum is lost. And here is a part that catches people off the guard. Even if those 2 nodes have all the copies of your data, Vertica still shuts down the cluster on purpose. Why shut down when data is right there? It's basically to prevent split brain. If the cluster splits into 2 halves and both kept accepting the writes, you would end up with 2 conflicting versions of your database and no clean way to merge them. That's the reason Vertica shut down the cluster. I hope now you understand the difference between the 2 safety rules. K-safety keeps your data available, Quorum keeps your cluster consistent. So in enterprise mode, you need both. Lose either one and Vertica stops the database to protect your data. System is a built-in monitoring table, 1 row cluster wide, always current. Query it anytime to check your fault tolerance live. 3 columns tell you the whole story. Node count, the total number of nodes in your cluster, here it's 5. Node down count, how many of those are down right now? Here 1 has already failed. And the one that matters the most and important is current fault tolerance, which is basically your live K-safety level. It basically shows how many more nodes can fail right now before the database can become unsafe. Here it's 1. So with 1 node already down, the cluster can still lose 1 more node and keep running. Now here is why you watch this number. It falls as the node fails. So make this query as a part of your monitoring. If the current fault tolerance is sitting at 0, then you're 1 node away from the outage. That's your signal to recover a node faster. So it's 1 table, 3 columns, and you always know exactly how much safety margin you have left. K-safety copies every segment to second node, so you can lose a node and keep running. But there is a gap. What if that node and its buddy are sitting on the same rack and the whole rack loses power? Both copies are gone at once. That's exactly what fault groups are built to prevent. Let me show you with a simple example. Let's define what is fault group. A fault group is a set of nodes that share a single point of failure, basically the same rack or the same network switch or the same power feed. If that one thing dies, every node in the group goes down with it. So you tell Vertica where those boundaries are. Rack 1 is one fault group, FGA, Rack 2 is another FGB. Now Vertica knows your physical layout, not just a flat list of nodes. On big clusters, Vertica handles this for you. Once you cross 120 nodes, it automatically switches into large cluster mode. It designates a subset of nodes as control nodes, the ones that manage cluster messaging. We'll review that topic very soon, and spreads those control nodes across your fault groups. So no single physical failure can knock out too many of them at once. Fault groups can also nest. A parent group can contain child groups, so you can mirror layered boundaries. A data center holding rows and rows holding racks. Here fault group B splits into fault group C and fault group D, and fault group E is split into fault group F and fault group G. The structure follows your real world domains. However, there is one important caveat. Fault groups basically make Vertica aware of your topology, but they don't add hardware redundancy. So a single switch with no backup is still a single point of failure, no matter how you group it. So protect your switches and power paths at the infrastructure level too. So the key takeaway is your fault group structure should follow your physical fault boundaries, so your data always lives across the groups and never gets trapped inside one single rack. I hope everyone got clear picture. If you found it useful, please do like, share, subscribe and hit that bell icon for regular updates. Thank you.